Do you have board here? No, you don't have board, no? You don't have board. Writing board here.
You need a pen, maybe. No, there are two pens, but I don't know if they work. So maybe we test them first. You do this while I introduce her, maybe.
Yeah.
All right. So, well, thank you for those who came in person and for those online, which I'm not seeing right now. But thank you for being with us. It's my pleasure to introduce you to Dr. Shivani, which is the Dean and Faculty of Shastras, Head Department of Vyakarana at KSU Bangalore. She gave us a lecture today titled Bridging Traditions and Technology, Exploring the Synergy of Digital Humanities and Sanskrit Computational Linguistics. I know that Professor Shivani was introduced already yesterday, and for most of you, she is well known, but perhaps there are some who don't, so I will give just a brief introduction who she is, and then you may please proceed. So Dr. Shivani is Professor and Dean of the Faculty of Shastras, as I say, Head of Department of Vyakarana at Karnataka Sanskrit University in Bangalore, and the editor of Karnataka Samskrita Adhyayanam, Vidvat Patrika, research journal brought out by the KSU. She pursued her doctoral research on a computational model for linguistic studies of Sanskrit, Balakanda of Ramayana, as a case study, followed by the Masters on the Natural Language Processing and Sanskrit Vyakarana. She served as Deputy Director in the Chinmaya International Foundation, Shoda Sanstan, Kerala, and also as a guest faculty member at the Department of Sanskrit Studies at the University of Hyderabad, as well as the Department of Shabdaboda and Language Technology, Rashtriya Sanskrit Vidyapit in Tirupati. She also has co-authored a book titled Key to Karaka. That must be quite useful, actually. I wish perhaps I shouldn't have a look, because Karaka is pretty much the foundation, of learning the language. Obviously, she has several journal articles and conference proceedings to her credit. So it's my pleasure to have you with us today, Shivani, and I leave the floor to you. Thank you.
Thank you very much. So, thank you very much for inviting me. Head of the Department of Srinivas. I just want to know your background. You please introduce yourself.
My name is Akanksha. I come from Hyderabad. I've done my undergraduates in animation.
Animation.
My name is Varsha. I study in Department of Languages, second year. I come from Bangalore.
Okay, thanks.
I'm Musical Superior, faculty from CSC Department, MIT in Wellington. I'm a part-time PhD scholar working on machine translation.
Machine translation. Good. Okay.
Srivacha, I'm a house okay. Department of Tourism staff.
Please.
Sarvesh Sangulkar, I'm from Nagpur, and I have completed my bachelor's from BC. Yeah, and my master's in Indian philosophy.
Okay. So in machine translation, what are you machine translation?
Yes, ma'am. I'm working on Kannada English machine translation.
Kannada to English.
English.
And vice versa.
Vice versa.
So what is this one? Statistics or machine learning?
Neural, deep learning.
Deep learning.
Based approach.
So what is the status now?
Right now, I work on the baseline. Previously, I used to take up a course here under Dr. Arjuna Sansam. So, as part of that, I have created rule-based Sanghi generator for Kannada local Sanghi, and also morphological analyzer.
Oh, it is available.
Sanghi, yes. And with respect to the morph analyzer, we have communicated a paper. Once it is done, the codes will be available now.
Okay, so you have prepared this, you have dictionary and all.
The Sanghi is purely rule-based, and we have not made use of any dictionary.
For morph
analyzer, we have used Hampi University's Sankshipta Kannada Nighanta.
Oh, then you have that database.
That database we have paradigm-based approach using a
paradigm-based. So, see, I am working on Sanskrit computational linguistics. Okay. You know what is computational linguistics? Because you are from most of You are from computer background, no? So you may know. What is computation linguistics? What is linguistics? You are linguist, no? What is linguistics?
Linguistics is study of how the formation of the words and how we like computation using machine learning, how we mix up computer with linguistics and bringing up.
Computation linguistics? You have basically seen computation. What is computation linguistics?
It's basically using an AI to communicate with, like an AI, artificial intelligence for communicating with the things that I don't know and I want to know, like Google Translator and stuff.
Everything, computation. Then Sanskrit computation linguistics. If you use Sanskrit, Sanskritam, no? Concepts. Sanskritam means it's not just letters and all, I, script, nothing like that. See, concepts, Shastra. What is the Shastra? Science, no? What is science? What is science? Shastram. See, here, Vashini Mahodaya, what is Shastra? Kim Shastra?
I'm not going to
No,
get
it's
into
this
the
Lakshana.
So basically, the text it's a group of it's a science, and the science that is communicated in the form of text that describes about certain worldview, that describes about the philosophical discussions. So, and in Indian context, it is also said it is not merely theoretical in nature, but it is also practical and applied in nature. So, the one who discusses it is also should practice it.
Vishnuvardhan Mahodaya, what is it? Shastram nama kim? Sanskrit.
शास्त्रमित्यस्य शिष्यते यथावस्थितम् अर्थं प्रतिपद्यते यत् तत् शास्त्रम्.
See, that is the beauty of Sanskrit. If I ask you what is science, you have to explain this much. Okay. But in Sanskrit, we have definition for everything. Lakshanam we say. We can say Sabdat Kaha. We have definition. Kim Nama Vyakaranam. We have definition. That is the beauty of Sanskrit. Shastra. Shasti is Shastram. Okay. So, nowadays, what if you see this IITs and all, IIT and all, they all are focusing on Sanskrit. All means at least in India. So we ourselves we are working on machine translation. Machine translation from Sanskrit, Kannada, and Hindi. Okay, to vice versa. Sanskrit to Hindi and Kannada, Kannada to Hindi and Sanskrit, like that. We are working on 3 languages. Machine translation. You know what is machine translation? What is translation? Anuvadaha. Anuvadati. Anuvadaha. Anuvadati nama, gacchati means going. Anugacchati is following. So, anuvadaha. Anuvadaha means something is there, so we translate. Anuvadati. Kim karoti. Anu means it's a following like that. So, anuvadaha, translation. Machine translation means? What is machine translation?
Involving the computer in the translation.
We are translating through machine. Machine is not just like this, okay? This machine like yantram, it's not like that actually. We cannot do that. Machine means it's a tantram. Yantram means there is a tantram. Technology, we are using technology. Through technology, we are translating. So nowadays, Sanskrit is the interlingua. They want these IIT people and all. They want to use Sanskrit as interlingua. What is interlingua? Language related to language. Interlingua in between. Okay. So we take concepts from Sanskrit Shastra. Sanskrit means it's not just spoken Sanskrit. That is actually one aspect. Speaking Sanskrit or writing, not like that. Sanskrit Shastras. We have Vyakarana, Nyaya, Mimamsa, etc. So we extract the concepts from the Shastras and apply it in computer. Okay. So because we are linguists, so we work on languages, not another part. Okay. Means languages means machine translation, like they're not creating tools, developing tools like morphological analyzer, generator, and speech to speech, text to text, text to speech to text, even translation. All these things come under this computational linguistics. So when we involve Sanskrit there, then that becomes Sanskrit computational linguistics. Okay. So do you have any specific questions to learn or something like that? Then I address that. Then I'll go to what we are doing. I'll show you, present to you what we are doing exactly. Any question?
Question about interlingua.
Ah.
So interlingua can be irrespective of the language that we consider. It is a general representation as what.
See what we can do, no? In machine translation, okay. In machine translation, what we are doing, this is source language. We are translating to target language. Huh? Source language to target language, we translate. But no, see, this is you now you are working on Kannada to English. No. So for working this, doing this, if you want to read a paper written in Kannada, what you have to do? No, you translate this into English. And again, if you want to translate Malayalam to English, and each one is separate, okay? And now for, if you want to understand something, now I am a Keralite. I know only Malayalam, you think. Okay. So I want to read one Kannada. So some person, intermediate, well, some person should be there, he's a mediator. He should know Kannada and Malayalam. You know? Because he has to understand the Kannada. See, these bhashas are there, no? When they speak, ministers and all, when they speak, he has to understand his language and he has to understand my language, then only he has to explain. No? Vibhashi. So like that, so for each language, then we need people. But see, if you take Sanskrit has very, very concrete, very solid formal grammar. Okay. Where everything has Lakshana definitions and it's very much formalized. Yeah. So what we do, but no other language has that solid, that formalized grammar formalism. Okay. So we have Ashtadhyayi. You know Ashtadhyayi? Have you heard about Ashtadhyayi? Ashtadhyayi is the grammar text. Ashtadhyayi. Okay. So this has everything. So not only for Sanskrit, so this at least for Indian languages. Okay. Almost all see any grammar, if you take any grammar, some specific any language, some language specific rules may be there, but most of the concepts are applicable to any language, at least for Indian languages. For example, Karaka and all is universal concepts. Okay, that I'll take you to later. So what we do, no? So we analyze the structure of the language. Okay, for machine translation. Now we are working on these three languages. What we do, we know the Sanskrit. Okay, that's why now Sanskrit has high demand. No, you see, we have a consortium project for machine translation. There are 3 IITs and 1 IAC and CDAC. Only one Karnataka university is Karnataka University because they need Sanskrit. Okay, so what we are giving the concept actually. See how does the language work? We know the structure of the language because the structure is explained here in Sanskrit. So once we understand the structure of Sanskrit, we can understand the structure of any language. Okay, so common structure is there. So what we do, we make this a mediator. This is the mediator. That is interlingua. And Kannada, Malayalam, and this Telugu, etc. What we do, see, we translate these to mediator, means Sanskrit. This will go here automatically. So one mediator is enough. If you do like this, you need many rules. Okay. So we are making this as interlingua. So Kannada needs to be translated here, then automatically it will go like this. Like this, this will be the mediator. That is interlingua.
So will it be a mathematical when we consider machine translation? Will interlingua be a mathematical representation or will it be like
Rule-based.
rule based?
See, we have many methods actually. This can be rule based. You know what is rule based? Rule based, statistics based, or deep learning or machine learning. Machine learning. See, rule based means this Ashtadhyayi is there. Ashtadhyayi means if Ikara is there, okay, and here it's Swara is there, then this becomes Diya. This is the rule. For example, see, replacing a letter with another letter. That's a rule.
You write this in HTML or
This is Python. Python. HTML for this display, no? That is the interface. HTML. That we are using PHP. Python, now we can use Python itself.
the JD they were teaching this was HTML. That's why.
HTML now, HTML, XML now, we can use PHP or Python. I like that. Thank you. So this rule based, no? So rule based, no? Rule based means, so this is the rule. Okay, if Ikara is there, and this is the condition Swara followed by Swara, then we have to replace it with Ya. This is the rule. So when we program, no, we give these rules. We use these rules. Like you said, no, that you are using rules for morphological analyzer. No data, no there's no statistics or no machine learning, nothing. They use the rules. Then no, some it's like Utsarga Dapavada. Utsarga Dapavada. Utsarga means common rules. Then Apavada means exceptional rules. Okay, so common rules and normal general rules, then exceptional rules we use. This is rule based. So then we will go to the rule and check and do this. And another one is statistical based. Okay, we take statistics of the this. No, actually we are not using this. Nowadays people are not using this all this method. So machine learning is now everyone is following machine learning actually, deep learning, because now we have huge memory. No, earlier we didn't have memory that much. So now we have huge memory. What we are doing now, we store all the words, sentences, even we have to translate the sentence. We store the sentences itself, text, gold text. We just read and make gold text. Translation also we make gold data, maximum. Then automatically when you create new sentence, then automatically machine will learn because huge data it has. So it itself can, that is AI, no we use. It itself can make out. So what is the structure? If I use Ramena Saha Gachati, Ramena Saha Gachati. So machine it itself understands that if Saha is there, then it should be Trivia. Okay, it should be Trivia. That machine learns. From the database, machine learns that this is no, because no, it sees the probability and it makes out that Saha is there, then this. Vinay is there, then Vidya. Like that it gets it, understands, okay. That is learns. That is deep learning. Then now when we give that new sentences, when we use if Rama, instead of Rama, if we give something else, automatically this learns the grammar and that translates. That is deep learning what you are doing. No?
Community is a parallel corpora, and based on the the words available in the parallel corpora, we build a vocabulary. So if the data is like gold standards, then we get better translations. If not, we get bad.
Yes. But even in neural learning, you need to have the whole corpus itself is the
dictionary is must. Dictionary, no, few people don't use dictionary also. Even if you this is available because this translation itself they keep. Okay, this all translation. Once you translate, that will be the database. See, whoever now Google also does like that. When you translate, that goes to the database. Okay, everything is stored. Nothing is deleted. Okay, whatever we use there for translation, even OCR, OCR, we do OCR, no? That Google Doc and all. So that will be stored. That data will be stored. They are using again and again. Okay, that data. Like that they use for deep learning. That's why this correction process, no? But complications are also there.
But that is also almost statistics in the newer form. It's a new statistics.
This is not
Because
statistics. Statistics means no. We say this Saha is used this many times. It will take statistics.
Here,
Based on the statistics, they will see the probability. So then, based on that, they frame the rule and they do that. Statistics. Here, we are not using anything machine learning. Even you don't need dictionaries. You don't need dictionary. You don't need morphology analyzer. No, don't need morphology analyzer. Nothing. Just data. Data and it will no rules. Nothing. So from the structure itself, machine automatically learns.
in Indian languages, the interlingua is Sanskrit.
No, see, one team is working on this, as this is taking, they are taking it as interlingua.
Okay, so in Indian,
And for Ansaraka also, that is rule based, they are also using this as interlingua. This IIT Hyderabad Central University Hyderabad, they are all using Sanskrit as interlingua.
no, my question is different. So in Indian languages, if someone considers interlingua as Sanskrit, now what many people, for example, in European context, do they use interlingua, something, a natural language, as an interlingua? Has this
Actually,
process?
so far, I haven't come across like that. They are using deep learning actually. This, most of them in West, they are using machine learning. But we experimented this. No, we have the Sanskrit machine translation system. So we did for Pali language. Okay, Pali language. You know Pali, Buddha's theories and all are written in Pali. So what we did, no, see, we have this is also paradigm approach. You know what is a paradigm? You explain.
Paradigm is with respect to, like, let's say we have reduced some set of rules and we try to code those rules with respect to a certain category of words. Like when a new word comes into picture, we try to map it into certain paradigms. So predefined set of rules, I guess.
Actually, paradigm is also well defined in Sanskrit. Paradigm table we have. You know, madam, you studied Ramaha, Ramo, Ramaha, Ramam, Ramo, Rama. That is a paradigm table. Pathati, Patha, Pathanti, Pathasi, Patha, Pathatha. That is a paradigm table. I'll explain to you how. So you want like this, or shall I show my this? This is okay. No? See, for example, this is a Patha Dhatu. This is a root. Okay. Pathat is going. So this is the root. Go. Root means go, going, go is the root. This is the root. So see, Patha has these many forms. Pathati, Pathatha. You need not understand this. No? You just take it as a table. Pathati, Pathataha.
Better, I think you use the other pen.
Pathanti. Okay. Pathasi. Pathatha. Pathatha. Pathami. Pathavaha. Pathamaha. See, this is he goes. He, Pathati, Pathatha, Pathanti. He goes. They two are going, and they all. Here, Tvam means you. You go, you go, you go. That is, you go, you two go, and you all go. Tvam Pathasi, you am Pathatha, you am Pathatha. For singular, dual, and plural. Here means I. I Pathami. We two Pathavaha. We all Pathama. This is a table. This is for present tense. Okay, this is for present tense. So if you know this, all roots, see one list is there. all roots similar to Patha will be having table like this. Okay. For all forms, this is a table, paradigm table. Adarsha Rupa is there. Adarsha Rupa. Paradigm table means Adarsha Rupa. Adarsha, you know, role model is, you know, he is my role model. Like that. This is the Adarsha Rupa for all forms similar to Pada. So this will take us Adarsha Rupa. If some Bhu is coming, then we say this will work like Pada. That is a rule. Based on paradigm tables, we frame rules, then we generate forms, right? So doing the same now?
Yes, ma'am. We call it the inflection table.
Inflection table. This is inflection table. See, what is inflection? This is Pat. Inflecting to Patataha. No? Inflecting to Patataha. Inflecting to Pathanti. Yes. That is inflection table. We call this as Kim. We have Dhadu Rupa. These are Dhadu Rupas.
What is it? Lat, lakar, lang, lang.
This is letter. This is letter. Yeah, this is tense. Present tense. Present tense means letter. This is a technical term, letter. Letter. So you got it. So this is the this now in machine translate they call this paradigm table. This one. Adarsha Rupa. Adarsha means mirror. Mirror image. This one, no other, all other things will behave like this. Then like that we have different paradigm tables. See, in Sanskrit we have different ganas. Bhuadi gana, Hadadi gana. So one gana, complete gana behaves like the first form. So the first root, we take first root from out of this gana and we make this paradigm table.
Do you have to enter all the verbs, the Gana, or the computer learns it by itself?
We have generators. See, if you make this particular, you take one from Gana and make one table, then other Gana you have to give just roots. Okay, they will create this. We have that we say morphological generator.
Okay, so you give
Okay.
the roots and then the computer understands it.
Yes, we have. See, you can. I'll share with you this link. We have morphological generator and we have morphological analyzer. Okay, so I'm coming to morphological generator and analyzer. No,
But how will it be for like irregular words?
what is the irregular word?
Like some won't be in the same format.
Then exceptional cases, anywhere, everywhere exceptions will be there. Even in your life. Okay, so everything will be okay. In some cases, that is exception. That will be there. No, we say no, he's so calm. How can we be calm like this? But sometimes he also works out. Like exceptions, everywhere exceptions will be there. If some irregular verb is there, then we have to handle separate them. For example, see if you take Rama Shabda. Rama Shabda and Deva Shabda. Okay. This is Deva. So in third case, we write this Devena. Okay. Rama Shabda, this both are same, no? Akara, Akara. But this is Ramena. So for machine, because this is, the difference is there, no? Na and na. So for machine, we know this is same paradigm for us. But for machine, this should be two paradigms. Got it? So we exceptional cases, we have to take another paradigm. New paradigm. We have to add paradigms. Adarsha Rupa should be different.
And then you call this paradigm like according to Panini, so you can kind of say when they're.
See, according to Panini, what Panini does, no? Panini rules tells whether this is correct or not. What all you are generating. See, this Panini's machine is like a not machine. You know, not machine in bank. No. So you have to just keep it like that. It will within seconds it comes out. If it is good, it says okay. It's not, ruled out. Like that machine, Panini's system is there. This is Panini's system. So this one word if you enter, if it is Shuddha, it comes out. Otherwise it will be something, some error it will show like that. So Panini Centra is used for getting the sadhutva, whether that is correct or not. So see for this generating these forms, no, we can use Paninian rules.
That's what you do. Okay.
Yeah. Then you get correct output. If it is not there, then you don't get correct output. Okay.
So Vriddhi Radesh becomes a code.
Yes, with Vriddhi Radesh becomes a code. Eco energy becomes code. Those are the rules.
But this happens only at a more than a morphological level. It happens only at a character level.
Morphological level. Because see, morphological level means this. It's not character level. Because so many changes are there according to this prakriya that not till from a root till this padhani, so many processes are there.
Okay, fine. Even if it happens at a morphological level, because if we consider Suttingandam Padam as one morphological unit, then it happens at that level. Now, what happens? Now, this rule-based approach, does it really function at a syntactic level where machine learning or AI needs at a syntactic level?
Actually, for me, if you ask me whether deep learning and I prefer not only rule-based, both together. Because even if you do this deep learning, machine learning, even machine cannot fix the bugs actually. No. So sometimes it works odd. Some other, but they cannot fix where this machine has gone wrong. They cannot fix it. That's why now IITs are taking Sanskrit as interlingua. Otherwise, they don't need interlingua. Okay, then they can fix the bugs. So for me, according to me, we have to use some rules also. Otherwise, it's disambiguation. No? Disambiguation means sometimes that see, for example, words are having multiple meaning. Multiple meaning. No? How do we handle that? We need context. For example, the bank. Word bank. What is the meaning of bank?
Bank of a river, there's a bank account.
A river, bank, Vitta Kosha, and all. Then how do you fix the meaning? What is bank in particular context? We have to see what is here and what is here and all. Then only we can fix the meaning. Okay, like that Hari in Sanskrit. Hari. Hari is a Simha lion. Hari is Vishnu. Hari is a monkey, so we have some 30 plus meanings for Hari. So, how do we fix the meaning? So, machine may go wrong. Okay. Anyways.
No, but this also works at only at a semantic level. Now, what about
syntactic level, not semantic level.
No.
Syntactic level.
When you are speaking about examples like bank, but what about pragmatic uses like, for example, idioms and phrases?
That's why. See, even machine translation, machine translation 100% we cannot translate to machine. That is one. For pragmatics also machine learning, that is we have to take it as it is. We have to have a database like that. Okay, that was machine learning.
That is statistics.
No statistics, machine learning. Because they take, see, for example, Devanam Priyaha. Okay, Devanam Priyaha. We cannot take Devanam and Priya. Devanam Priyaha is a fool, no Murkha. Actual meaning is Devanam Priyaha means it's a Devasya Priyaha. But that is not the meaning here. We have to take this as one unit. We have to take it as Murkha. Okay, how do we get that meaning? So this usage, machine learns this. We translate this, first of all. So then this learns this. Whenever this comes, it will take together. That is the learning power of a machine. That's the power of a machine actually. It learns some instance because lot of huge data, you dump data from all texts and all. No?
Yeah.
Any questions?
No.
Oh, Sama, agree, So any other question? Is it clear?
Yes.
Anything else?
Now also with respect to the idioms what sir pointed out, like when we are doing with respect to a machine, obviously we come across sentences like we will in the gold data we do not have any idioms as such what we are using. So how do we tackle if there is idiom or something? Because the context, yes, it does matter with the sentence. If the machine is not trained on a particular context, then how will the machine cope up with that kind of thing?
See, actually, for idioms also in Sanskrit we have separate data, idioms data, okay, idiomatic data. No other way, because even we don't understand. No? If we know, we know. Otherwise, we don't understand idioms. If you in English, if you use something, I don't understand. Because we need practice. Even for human being, we need practice. Otherwise, you don't get it. Even in Malayalam, if I use some slang or something, you don't understand. No? Because we are not practiced. So same thing with machine. So we have to teach them. Teach the machine. How do we teach? We can have separate database for idioms, like dictionaries, no?
The lemma has to be put in.
We see for lemma also no. Yes, the whole thing we have to put.
That's entire entry is the lemma.
In there, this thing, whole sentence we should put. And the meaning also we should have. We should have to translate and keep. Okay, for example, in Sanskritam, few samasas. Samasa is very difficult to translate samasas because samasas can be, see, Rameshwaraha, for example. Rameshwaraha. What is the Rameshwara? Rameshwaraha. This can be like this. Ramaha. Ramasya Ishvaraha. Rama is a person. We take it as X, and his Ishvara is Rameshwara. Ramasya Ishvara. Ishvara of Rama. What else is possible? Vishnu.
Ramaha Ishvaraha Yasya.
Ramaha Ishvaraha Yasya. This means one who has Rama as his Ishvara. Okay. Okay. This is Ramasya Ishvara. Rama someone and he has one Ishvara, that is someone else. But here Ramaha Ishvaraha Yasya. So here Rama, one who has Ishvara is Rama. Any other possibility? Dvandva is not possible.
Ramascha so Ishvaras.
Ramascha so Ishvarascha. So Karmadharya. Ramascha aso Ishvarascha. Ishvaraha. What is that?
Rama himself.
Rama himself is Ishvara. So we are getting three meanings out of it. How do we translate? These are the challenges actually in machine translation. How do you do that? It's purely context. Even we cannot get, it's no human being also are confused getting this meaning out of it. So not only idioms, we have problems with other other cases also.
But how this kind of endocentric and exocentric?
See, first what we did know, earlier, some 10 years back when we were working on machine translation, what we are doing, we are having this, we are tagging, tag. What is the tag?
Auto speech tag.
So like that, we are adding some signs. Okay, for example, if this is called Ramaseshwara is a Tatpurusha Samasa. Okay, so this is T we mark. And this is a Bahuri Samasa, so we mark B. And this is Karmadharya, so we mark K. Like that we were adding then we are asking machine to learn and do that. Okay, that was one problem. And one more problem I will tell you. See, Pitambaraha. Pitambaraha. Who is Pitambaraha? Who is Pitambara?
The person who wears yellow color clothes.
Vishnu.
Vishnu.
No, Vishnu is Pitambara. Means Pitam Ambaram is yes. So here we use dictionary, no? In dictionary, this Ambara Shabda, no? Ambaram. Ambaram is Vastra, dress. Okay, cloth. Ambara is neuter gender. Okay. In Samasa, it becomes masculine. This information is not available in the dictionary. Then how can machine work? These are the challenges. Okay. So challenges with Samasa, compound words.
The machine learning by putting more and more text in
That's
the.
why software engineers say no, we don't want the rule based, it's complicated. Because of these challenges and contextual, they say no, we don't want this. This is complicated. That's why they use deep learning and not machine learning. So they dump the data and they ask machine to learn.
So in that sense, corpus linguistics is gaining more advantage over in
But they are facing problems also.
But in corpus, unless they tag, how the computer can understand
Now
the
they are
corpus?
tagging. See, they are tagging. They are even this morphological analyzer, huge data, they are tagging and putting. Tagging and putting. That's it.
So they put the text in the data bank and they tag the text.
The data bank, huge data bank for each language. They are creating lakhs and lakhs of sentences, translating. There's no that bilingual, trilingual, like that. They are translating and creating this data bank.
But they take actual text, in one sentence. Yeah, they take actual text.
And they learn the structure actually. They learn the structure when you see it's like X variable. It's like a variable. So this can be changed. See, for example, in Sanskrit, in English also, Ram goes, no. They learn this part. Go, this part. This then this connection. They take maximum structure connection and they learn. Then they analyze the same. See, for example, now we say Ramaha. Ramaha can be verb or Ramaha can be noun. Rama can be used as a verb or noun. So then they'll see what are the possibilities. Okay, so they see, and most of the times Rama is used as noun. So they take this as noun, like that. And they see the position, everything they see. Okay.
I have a question in case of compound words. In case of Dutch or German or Sweden, the compound languages, there also there are exocentric compounds where the meaning is outside the given morphic unit. Now,
In English also.
Have the Sanskrit people tried to interact with how these other languages function in case of artificial deep learning? And have they had any conversation on this front?
Not with French and all, but we
French they don't have, only North Indian.
But no, in English also they have actually. For example, water pump. What is the water pump? It's a samasa. What is the water pump? What is water pump? No, it's a samasa. We don't think actually. But no, why in Sanskrit we take because that is defined. But in English also, we have water pump. We use every day. Red hat.
The person who has red hat.
No, you have no. How do you handle that?
No, how Sanskritist and
But they are not. No, they don't have. They say quasi compound. Ardha samasa. They say that in English water pump. No, the pump that pumps water. No, that water pump. That's the Vigraha Vakya. Something like that. Okay, something like that. But water pump is a compound word. How do you handle it? See, they are not handling like this. What we do. Water pump, they say water pump is equal to something like that. They are taking as one unit and analyzing. But they can do that because see English no. Ram goes to school. No. Here, this case marker is separated. Okay. Case marker is separated. But we, in Sanskrit and Indian languages, this this information is, so case marker and all is attached to the stem. For example, Ramena. So we cannot separate this. That's why samasa is important. We have to handle samasa. Because that case marker, all information, linga, vachana, everything is attached to the stem. But this is not like that in English and all. So we have to analyze the components. Not only for Sanskrit, all Indian languages you have to do this. In Malayalam also we say Ramane. Ramane. Okay, this A. That is attached. That information is coded within the word, not outside the word. We cannot separate that. Srinivasa. Anything else? Then, so you are interested in machine translation. I'll show you first machine translation. Okay. So this is Sambhasha. See, this is our web portal. So Karnataka Sanskrit University at Vyakarana Vibhaga, we have a department of Vyakarana. So there is a team. Team means they are working. Actually, we have a course program, PG Diploma in Sanskrit Computational Linguistics. Okay. So there are no their students have to do projects throughout. So 1 year program. So they have to, when they join, they have to start working with us on various projects. And finally, second semester, they have to have their own project actually. They have to make. So we support and we give the concepts and they have to do. Like that, no, our students have done a lot actually. So we start some projects. If they cannot complete, next year we'll take it up and complete it. Part by part we do. So here this is Sambhasha. Sambhasha. What is a bhasha? Bhasha is a language, no? But when we add some, it has different meanings. Okay, various meanings. Some nama we use it sanganaka. Sambhasha. Sanganakasya bhasha. Language of computer. That is one meaning. And Sambhasha is used for samvada. Samvada. Samvada means charcha. No, like the discussions. Samvada, vada, debate. Like that. So many meanings are there. And that's why we put this word, Sambhasha. Okay. So this is our web portal, Sambhasha. So here what all work we do, most of the work, we cannot change this.
They would work on server restart.
So this is the Sambhasha. We have this, here you can see the courses what we offer. We offer online courses, means short-term courses like this Gurukula Swadhyaya. So here what we do is, this is, Gurukula? What is the Gurukula system? So you have to sit with a guru and learn from his mouth. So you can ask, that is a parampara, that's a tradition. So here what we do, it's an online Gurukula. One traditional guru will be there. That is early morning by 6 o'clock we start, 6 to 7:30. So online, but it's exactly like Gurukula tradition they teach. So like that, each and we take Shastric texts. Shastric text means science, text based on science. So Vyakarana, we had Mahabhashya. We started with Vyakarana Mahabhashya. It's a commentary on Ashtadhyayi. So like that, we have so many courses. This is Prayogika Sanskritam, functional Sanskrit course. Everything is online, okay. And science of Natya, dance, Natya, no? Natya. So science behind the Natya. Like that, we have many courses, online courses, workshops and all. So that is available here. And research team, everything, resources we have. This is the project part. So few projects are funded by the government, central government and all. Few projects, students projects. Okay. So here first I'll show you Pali, machine translation. This is Sankanika Pali. Okay. Sankanaka nama computer. Sankanikam, computer sambandham, Pali. Okay, so this means it's the Sankanika Pali has many tools. It's a suite of tools. See, it has machine translation, morphological analyzer, morphological generator, Sandhi tools, text repository. See, why we are doing this project means this Pali. See, now we have many languages. Many languages are almost extinct. Okay, so it's not they put under Oriental studies. Now they are not using like that. So, but no, it has a huge data, means text. Knowledge. Knowledge means culture, knowledge, shastra, everything. So when we lose the language, we are losing the knowledge also. So for preserving that knowledge, we have to protect save the language. That's why we started with Pali. Pali, now we are working on Prakrit. Like that Kuvi. So many languages are there where we have knowledge, but this no language is vanishing. So we did for Pali. So this one, no, we what we did, no, we know Sanskrit, okay. We don't know Pali. One of my students, Swati Pesapur, she did this work for her PhD. So we know Sanskrit grammar, but Pali we don't know Bhasha. Actually, we didn't know even was a single word of Pali, but we just explore. Okay. So then we, based on this, no, keeping Paninian grammar in mind, we just looked at the Pali sentences. So when we found out that the structure is same, so then we started learning. Pali also has 3 grammars. It's a very rich language. Okay, so it has 3 school of grammar. So then we Satanidhi, Moklana, and all. Then we took that grammar also. We just read it. Then most of the rules generation, no, for word generated, we took from Sanskrita and understand the Pali also. Then we did this Pali tools. See, first I'll go to morphological. This is noun generation you did, no? Can you type here, Vishnu? Because I don't know whether in English. Where is he? Hindi?
Hindi अपेक्षितं.
Hindi or Sanskritam?
संस्कृतस्तावदना तत्र
Inbuilt अस्ति वा? Just Buddha you just type.
इन्बिल्ट् नास्ति तत् आङ्ग्लभाषायां टैप् कर्तुं शक्यते वा?
आङ्ग्लभाषेण भवति.
एवं वा?
You have
द्वयम् अपेक्षितं तस्य.
here in अस्ति, no, in English adu.
हाँ, more key languages.
Add language.
Sanskrit is there.
1 second.
Sanskrit.
This is which Sanskrit?
I will type.
You do, no?
This one is next. Install.
Where is it?
Just a minute, it will take time.
Okay.
Buddha, right?
1 second. Let me see whether the same.
B.
Okay, I'll do. I'm giving Buddha. Buddha is the stem, Pratipadika we say. So there is a Pullinga and it's a Namapada, noun, and it's a Prathama and it's Ekavachana. When I submit this, no? This Buddho. Buddho is the Prathama Ekavachanam. Okay, we get Buddha. And if we need the table, okay. Buddha, if I give, see, get the table like that. This is a generator. Means if we give the stem, any stem, this is X, anything you can give. So it will generate the table. So we see one system is ready means you can apply this for any language. You need not work on, you just need the database and paradigm table. That I'll give. So now this is Pali, this is available for Pali. Prakrit it's easy because system is there. Now what you need is just Prakrita exceptional rules and dictionary and paradigm tables, Adarsha Rupas. Then you can make, develop a morphological generator for any language, even your own language. So sentence means machine translation. See here, um, I give one example from here only.
But the example has to be in Pali.
This is Pali to Sanskrit. So we can vice versa also we can do, no problem. But we have to Tadhagato dhammam bhasati.
Bhashate.
Tadhagataha dharmam bhashate. It gives. Like that, there's no any sentence you give, so it will translate. This is actually rule based, not machine learning or statistical based. Rule based.
Generator, have you used any tools like Apersium or at the back?
Apersium. LT toolbox. This is the machine translation. This is based on Paninian grammar actually.
Even this is done using Apersium.
Apersium only. You are also using Apersium.
Right now I'm working on the neural model.
Neural models. This is Apersium. Okay, so this is machine translation. So here I told you, one of my friends. So here, first we have prepared a dictionary, bilingual dictionary, because this is from Pali to Sanskrit. So we should have a dictionary, Pali to Sanskrit dictionary, bilingual dictionary we should have. So like that we can add the dictionary. So we can have a big database. So this is Pali, Sanskrit, now Kannada we can add Telugu or French, like that you can do. But this system will be same. And we have to add exceptional rules. Then this will be for any language. This also based, we had Sanskrit morphological analyzer. Based on that, we did this. Okay, so like that you can do. This is Sanganika Pali. You can see this. Okay, I'll share this link with you, so you can go through this. This, we have Sandhi splitter, morphology analyzer, and some Pali texts are available here. Dictionaries, everything is open. This is open for public use. Okay, you can just refer like that.
Now,
So
for this rule-based method, what grammar Pali text that you was coded?
yeah, what we know, we have Samskrita generator. So we use the same Apersium and all. That is the technical part actually. Apersium, LT toolbox and all we use. But no, we have the format actually. So same format we used here.
But for that to generate
rules, we have three schools of grammar for Pali: Mokalayana, Sataniti, and Kachayana. Three schools of grammar. So when we see, most of the grammar, this Sanskrit grammar is applicable for Pali. But one thing, see, for eco energy and akasavarna dirgha, we have to know that a is there, and a will be there. No, but that actually this akasavarna dirgha is apavada, exceptional rule for this. But in Pali, no exception. Everything is optional. Okay, that is the specialty.
So there is no tripadism.
No, not necessary, because everything is optional. It can be a dirgha or it can be a.
Is it
Okay.
the option is by sound? If it sounds better, they use one or
Not like that. No, we have to see the usage. That's all. You can use this way or that way.
So that means for every this thing there is a vikalpa.
Vikalpa. They go like that. Why is must there? You can see the grammar. Why
In
is
all
must?
the three schools.
You know, everywhere. Why is must? Why we can have, even see, I'll show you the form. This no, that latta and all, langa and all, they have lot of forms because optional. Everything is optional. See, Panini, I'll show you one. Panini, Panini has categorized. And here he has given this Utsarga and Apavada rule. Means general rule and exception rule. But in Pali, it's not like that. Pali, they have sorted out. That's why Panini is great, actually. They have given what all are there, everything they have given. Okay. Rules. Not like, he is not sorting it out in Pali. But grammar, the Sanskrit grammar is very, very, very formalized, very, very structural. I'll show you that one form. See, this verb table generator, if you see, this is a pacha, sarvekala, it's all tenses. See, these are the pachasati, pachisati, pachasare, pachissare, pachassanti, pachissanti, all forms. No, all are optional. See, if you see these, see, these many options like this. Everything is optional, means everything is possible according to grammar. But see, the challenge is whether this is available, this is used or not, that is a challenge. You have to see Pali text. That had to validate.
Neural will be helpful.
Neural, yes. Machine learning helps. Because machine learning, they'll see the text and learn. Then the possible words only they will generate. Here that helps, because there, according to the rule, even according to the Pali grammar, all these forms are possible.
But the most Pali texts are liturgy, so I would believe that most of the Pali texts are liturgical, like they have to be sing.
Yes.
And so I would believe that the context is the beauty. Like in French, we also have words that you can say in different manners, depending, but normally we go for what sounds better.
Yeah.
So I guess for Pali, because it's meant to be
that is also possible.
Go for what sounds better.
But but the one challenge is, that is true, but here these many words, whether that is used or that is in usage or not, we don't know. Okay, but prayoga charanaha vyakaranaha, we have to depend on the prayogas, not the rules. Okay, rules, why these rules, grammar rules are used for this one, whether this usage is correct or not, we have to see. But it is, sometimes it is over generation. Over generation, because based on rules we are generating, but it doesn't mean that we have to use all the words. Sometimes it's not, because now this is not in usage, so we cannot generate and use like that. So whether we have to see whether that is available in text or not, pilot text. That's a challenge. So there, this deep learning supports actually. Deep learning, they see only usages. The duty of a grammarian is like that. We are not generating and asking the people to use. We cannot say that. Whatever you use, we have to give. You have to make rules.
I have two questions regarding Prakrit and Pali with reference to Sanskrit. Now, the Pali grammar, that there are three schools that you spoke of. Now, these, are they composed by a Sanskritist or a Pali person?
Pali, but they know Sanskrit also. Otherwise, they cannot. Even
their text, grammatical text. Do you find them influenced by Paninian system?
Yeah. Yes. See, even in Malayalam we have a grammar. Rajaraja Varma has written Kerala Paniniyam. Okay, but he says that is not based on Panini. He denies. But when we see, all rules are from this. Even sutras sometimes he has taken, but he denies that. He is not acknowledging Panini, but he has taken the rule like this. This also. This is Pali for Pali, but complete almost 90% is from this only. Even rules are like that. You can see the sutras. But this is few letters are not used in Pali, so that is the only difference. Otherwise, same. And the major difference is vikalpa, optional. So we can see in Paninian system, most of the case this or that. So we fix one. No, this is apavada, next va. So sometimes both are possible, but not in this. Everywhere vikalpa, va. We have to take. Okay, no. So next one a tool what we made is Ayush Samskritam. This is very interesting actually. So you can also work on if someone is interested in textual analysis, text analysis. You can take some. If someone is the students of Dvaita philosophy and all, they can work on. You can take a text, Dvaita philosophy text, and work like that. Okay, or any technical text. Technical means any Ayurveda or Nyaya, Yoga, anything. You can take a text and do this for your projects and all. So this is Ayush Samskritam. Actually, this project is done by Dr. Shivaja for her PDF, postdoctoral fellowship, there in Karnataka Sanskrit University. So what we do here, see then Ayurveda, yoga, and the tantra and all. All basic texts are written in Sanskrit. Okay. Actually, Ayurveda students they struggle to read. No, they have to, without Sanskrit, they cannot read Ayurveda texts, Ashtanga Hridayam and Chakra Samhita and all. See, translations are available, but few words we cannot translate. We don't get the name. Even Vakyam we say. Vakyam. You translate Vakya sentence. Actually, it's not. Vakya involves many things. Like that dharma. Dharma can be many dharma. Different kinds of dharma. So we cannot translate it. Like that, the translations are not, but no other way. That's why they have to depend on translations. But no, that's why what's happening. We have lot of manuscripts unearthed. Lot of Ayurveda manuscripts. That too, there are no Sanskrit scholars cannot do that. Cannot translate. Even Sanskrit scholars cannot translate Ayurveda manuscripts because these some words are technical. Technical means domain specific. For example, in medicine, paracetamol and all that we don't understand. Normally in Vyavahara, we don't understand that. That is a medical term. It's not that jwara, different kinds of fever. They have different kinds of names. Various names are there. We don't understand. Which is whatever doctor says, we obey. That's all. Like that, domain-specific words are there that even Sanskrit scholars cannot translate. So we need Ayurveda person to translate. Otherwise, both together to work. So for that, this Ayurveda, why these manuscripts are there unearthed? Because Ayurveda people cannot do that. Why? They don't know the language. Okay, Sanskrit experts also cannot do. They are doing, but that may not be. Scholars may be there, but very rare. Okay, because this technical terminology is there. No, that's why. So that is also so it's a collective effort. Otherwise, what they have to do is Ayurveda scholars must know Sanskrit. Then they can see because when I was working in Chinmaya, I got a manuscript, different kinds of jwaras. Jwara Timira Bhaskara is a manuscript. That some 100+ types of jwaras are there. So far, it's not published. People don't know that. Okay, so if they get to know, they can publish some papers. They can compare with the available fevers. Different kinds of fever, that dengue fever, this fever, that fever. We can see that whether this is available, some remedy is available or not. But that is not, no one knows. Okay. So for them, this Ayurveda people, for exploring, for reading the manuscripts and other original sources, they need to know Sanskrit. But how to know? How to do that? When we are taking years to learn Sanskrit, for learning one Shastra. So then they have to study 2 Shastras. One is Ayurveda, medicine, another one is language, new language, structure, Vyakarana, these and all. So that is impossible. No? For them it's impossible in 5 years. It's not possible. Impossible means they can work hard, but it's not easy. So what we did, we just did an experiment that we studied Ashtanga Hridayam, okay, linguistic. We studied, say, grammar-based Ashtanga Hridayam we studied, this was language-based. Then we analyzed, we made the statistics actually. Statistics means you said, lat. How many times lat lakara of a particular dhatu is there? Okay. So then we found lit is used most. Lit or vidhilim. Vidhilim is used most. So then they need not study 10 lakaras in all 2000 roots. They don't need to study. We ask them to study only ling and high frequency, frequency, there's no words. They have to learn that much only. They need not learn all the akaranta, ikaranta, ukaranta, kakaranta. No.
For the Ayurveda, you mean?
Yeah. So I'll show you that. So then Ashtanga Hridaya, when we did experiments, then what happens? We make a courseware and we train the Ayurveda students. In 6 months, what they can do, at least they can read Ayurveda Granthas. They cannot read Kavyas and understand all those things, but they can read Ayurveda Granthas, technical books, and they can do by reading one by one, they will get to complete that domain. They will be expert in that domain. So they can read these manuscripts with the help of some Sanskrit students or scholars. They can they can transcribe and all. That's why I show you that. So like this, you can also take some text, some technical text, and you can also do this. See, this is the text, and Ayu Samskritam. Ayu Samskritam, Ayurvedasya Samskritam. Okay. See, this is the first sthana. You can see this. This is the sloka. Okay. Sloka. So if you study any sentence or sloka in Sanskrit, first thing you have to do is patacheda. You have to split into words. Then only you can get the exact meaning. Srini, when you tell me when I have to stop, I'll stop. Okay, we stop, no? Okay. So this you can see this Ragadi Rogan is a compound word. Okay, Ragadi Rogan, Satsanu Shaktan. See, and this plus is there, no? This plus means Sandhi, means a joining. So this is the original sloka, and here we have split it. And the plus means there is a Sandhi. Sandhi means some joining of two letters. So when you click on the Sandhi, see, you get what is the Sandhi involved there and what is the rule based on Paninian grammar. So they see, then what we do, we take the statistics of these Sandhis. Then that much only, some 5-6 Sandhis they have to learn, not more than that. Okay, they need not know all the entire Sandhi package, they need not know. Okay, so like capsule, they have to know this much only, that we will provide in an understanding way. We make a courseware according to their understanding, not our understanding. Okay, so we keep that they are modern and they are newcomers. So based on that, we prepare a courseware.
A lot of Ayurveda students, they need to learn Shakuntalam and all.
Not necessary actually. If they need, they can read. Even
I have people in the family who have gone and
not necessary. No, learning is good, but no, for them they know they and Lekhu Siddhanta Kaumudi is there. Actually, that is not needed. They cannot learn like that.
1 year wasted.
No, not like that. No. That learning is good. Okay, it's not wasted. That is proper learning. Okay, Carl, you don't worry about that. That is a proper learning. But no, for them, because two field, they have to learn 2 fields, not 2 disciplines. That is difficult for them. After that, they can learn. But no, this is capsule like that. No, we'll do. First, we are providing this, and then we make a courseware for all. Okay. So if you see, this is Ragadi Rogan. Here, this is the Samasa. Okay, Samasa. The Samasa also we have statistics. Based on this, that much Samasa they have to learn. They need not learn entire Samasas. Not necessary. Dviku, this, that, and all. So if we see the frequency, according to the frequency, we develop the courseware like that.
Again, this is statistics. I mean, the impact of it is statistics.
This outcome is statistics based. Statistics based outcome like that. So this is the one, and statistics also. Statistics. Let me see. See, this is the statistics. Okay, this is the statistics we made. See, these are the lines, slokas, and adhyayas. And here this frequency, see. Akaranta Pullinga is more. So you have to learn one paradigm table, Akaranta. Then most of the things will be covered. Okay. See, second one is Akaranta Napumsakalinga. That's like that. Akaranta Strilinga. See, this one, Dakaranta and you need not learn at all. You can just ignore. Okay. This is the, based on this we can prepare the material. Like so now we have applied for a project. We do like this. Samayogi. Okay, Samayogi means Sanskritam, Ayurveda and Yoga. So we take texts and we provide, prepare courseware like that. Then for all Ayurveda college, we can train. For all Ayurveda teachers and students, we can train. All yogis know, everywhere they are practicing. They are not, this theory is not connected to, Shastra is not connected to the practice. So we can train. Wherever this Shastra, universities, colleges and offer yoga, there we can introduce these texts, courseware. They can teach them. So that they will be connected. So this is the one. So you can also see Sandhi statistics. See, these are statistics, Samasa statistics, and Vachana. Like that, no, we get everything. Morphological analyzer will give this statistics. And you see one more thing what we did, no, this is word inflection. That generation. Okay, so here also so you can see the akaranta. So akara adi. Okay, all words are listed out from Sutrasthana. If you go to one, for example, Agnihi, it shows Agnihi, the table, and here you can practice same thing. Okay, you can type here. If it's error, it shows the error. Okay, if it is correct, it shows this. This is for practicing. Like that, we can explore many things. Okay, these computer students know. See here, what you can do, you don't work individually. Now you have here the advantage of Manipal is you have computer software engineer students are there, and you have Sanskrit students, you have linguists. So you have to, these departments together, collaboratively you have to work. Okay, so for you have projects, take some project like this. This is something different. Always do some statistics, or you take some mathematics, this and all. No, for projects, computer students, you take something together. Okay, then you create something, and you can have a web portal for this. Okay, computational things. It need not be Sanskrit computational. So you can have any this one. You can have a student portal, Neeta madam. You can have something, and you can start working on, because anyways you are working. Okay, you do together. Okay, this is one thing. So I stop. Before that, let me see if anything important. See, many are there. This is this Mahakosha. One more project that data science students may be interested in this Mahakosha. What we are doing this we are collecting all koshas, traditional koshas. Koshas means it's a kind of dictionary, synonymous dictionary, we can say. We collect all koshas. Now, this, if you see kosha structure, it's very interesting. See this, the difference between the dictionary and koshas. Okay, that's the difference is it's a structure. These koshas are structured, and dictionary is in akaranta krama, no logic. But kosha has some logic behind it. So you can see it's like a blocks. Okay, it's a block kind of thing. Like, see, from one varga to another varga it goes. This whole kosha. For example, Amara kosha, the entire kosha is one unit. You can take. Okay. In between each chapter is a block. For example, Kshatriya Adhyaya. So all something related to Yuddha, drums, kings, everything will be available here. Okay. Sometimes what happens is Hari, Hari may be in Vanadhyaya, Hari may be in other Adhyaya, Devadhyaya. Okay. So this Hari, this meaning is fixed in this block. So when we compute this, we have to consider this block also. If we break the block, the meaning will be different. Yeah, I stop. So this is the kosha. So we are working on Mahakosha. Just I'll show you one and stop. See, this is the Amara kosha, what we are working on. This is one kosha. If I give this Vishnu, see, this is the word Vishnu. So it shows all connection in that kosha. okay, ontological relations, everything. Now this is here ontological as well as these relations. With Vishnu's Shankha, Vishnu's father. See what all are available in a kosha. Like that, Mahakosha means we are interlinking some 10 plus koshas like this. Okay, so this can be used for word sense disambiguation. In machine translation, for word sense disambiguation, we can use this. So now I'm not going to explain this now. So like this, we have many projects like this. This Anvaya Chitranam. Anvaya Chitranam is for studying. No, when you see, this is the representation of it. It's automatic. If you give any sloka, you will get in this form. This is a Karaka analysis. Means Karaka analysis. Means Ram goes to school. Means goes is a kriya, and who is going? Rama. He is a karta. And where is he going? This karma. Like that, it will automatically show. This is a karta. See, Nirpa is a karta, and this Visheshana, and this like that. It shows a representation, graphical representation. Okay. So then when it's easy to understand the sentence. Like this, you can do for Kannada, you can do for any language. The same tool is same. So this is done in Python actually, like this. Okay. Like that, we have many one last. This is the last one. This is in Shastra Granthas, okay, representing Shastra Granthas. This is a Tarka Sangraha, okay. This is Shastra mapping, I said, no, this is something like that. See here, this is ontological relations are marked here. You can, Padartha is, Drivya, Guna, Karma, Samanya, Vishesha, Samvaya, Bhavaha. These are the Padarthas. If you just click on Guna, see, these Gunas are 24 Gunas. These are the gunas, and this is the see here we get the definition or how many gunas are there and all gunaha. And if you click on rupam, see rupam is nila. These are the rupa, and chakshur matra grahya gunaha rupam. Like that, the definition also. So like that, this entire Tarka Sangraha is this one. Whole Tarka Sangraha text. Like this, you can do for Vedanta Sara, Sankhya Karika. Like that, you can take text and you can continue Vishnuvardhan. Okay, you people can do this. This is through XML tagging we are doing. Okay, so you just see all this, and I stop here. If you have any question, you can ask. So if you don't have time, we can leave. It's okay. So thank you for the opportunity to present.
Yeah. So.
Hello. Hello.
To have Professor Dr. Shivani here. She has been a long friend for past 10, 12 years, and we have been working together, and then she is here today. And the lecture, as the title suggests, Bridging Traditions and Technology. The way James Turner says this, today, even in the West, the problem is that the philology has been forgotten completely. But today, if at all modern humanities survive and it is advancing further, James Turner says that they have to be thankful to philology. And what we could see here, even in the West today, now the move is more than towards humanities. It's humanities is also becoming outdated. So the move is towards digital humanities, because the whole world, the whole data that's available, people are no more using the classical method and classical approach. So even if whether it is the digital humanities or the critical humanities or the medical humanities or even the classical humanities, but all of them, unless the whole corpus linguistics is available for them, the whole, whether it is humanities or social sciences, they can do nothing in their application of those theoretical knowledge. So to have that, how we could take help of the classical philology or even the digital philology, the study of language, linguistics, and literature, how we could make use of them was well displayed in the synergy of how we could work together. The computational linguists, the Sanskrit computational linguists, the theoretical and applied linguists, as well as the philosophers, the philologists, how we could work together to create such a huge corpus, a research base that could be helpful for the world in their everyday application of the knowledge. So, and even there are certain areas that Carl is interested, for example, the taxonomy that he worked as his PhD, and even Natasha she is interested in certain ways of dealing with. Her case is very interesting because a foreigner, an American who is very much interested in Paninian system, but does not have a proper tool to study it and how to apply it. So how I make use of it. And also Professor Shivani spoke of the problems that the Sanskrit world has. Even Professor Neeta pointed out that the Ayurveda, I was invited in an Ayurveda college to deliver a lecture. So I said that the Ayurveda students are purely learning medical knowledge from the Western texts. And Sanskrit they are learning only for scoring purposes. So there is no connect at all. Now the Sanskrit scholar in their lifetime can never be as Ayurveda teacher because they lack clinical knowledge. Ayurveda is not a subject that is like Nyaya. Even a Nyaya person cannot teach Mimamsa. Similarly, Ayurveda person cannot teach, Sanskrit scholar cannot teach Ayurveda because there is clinical knowledge that is lacking. Now, how we could work on this and how we could take the help of computational linguistics and the help of digital humanities to bridge them and create a corpus in which we can make use of that to train young scholars. So that was very well presented by Professor Shivani. We are thankful to you, and we have a very small souvenir, a token of appreciation from our end. This is basically our own publication house, MUP, Manipal University Press, and it's Sanskrit publication. So we hope that your books also get published here with us in Manipal University Press. They are published. She has a book with us in 2018, Karakarta Prabodhini, a linguistic work. I thought of that, giving us that as a souvenir. My office person said no. So
It's okay.
these are other books. Thank you, and we like to have you here once again.
Always. See, one more thing before we leave. See, few people, see, we extend any help from our side, okay, for this. But no, you start something like interdisciplinary something. I know your faces. No, I can read from your faces that you are interested in such things. So you can contact us anytime. We have a team. They are all helpful. Okay, and also we can. We have many projects. Students are working like that. So you can also join with us also. And we have this PG diploma. That's online in the evening. That also you can go through one course and you can start here like that. No, if you are interested, that is open. So anytime you can contact us. Thank you very much. Dhanyawadaha.
Thank you.